Assalamualaikum warahmatullahi wabarakatuh. For our group, we will be presenting about FTIR analysis of paracetamol. This presentation will be presented by FAUZIATUL NADHIRAH binti HILMI and me, Naziatul Amira binti ARIFFIN. So, what are the importance of paracetamol analysis? Firstly, FTIR analysis is helpful in identification of functional groups. FTIR spectroscopy can identify the functional groups that are present in a molecule or compound by detecting characteristic absorption bands. Secondly, quantitative analysis. Even though FTIR is primarily qualitative, it can be used for quantitative analysis by measuring the intensity of specific absorption bands, which correlates with the concentration of the compound. And lastly, it is important for purity analysis. It helps in detecting impurities in paracetamol by comparing the spectrum of the sample to the spectrum of the pure paracetamol. Any additional peaks indicate the presence of impurities or contaminants. While the FTIR method is used, molecular spectroscopy techniques, particularly experimental infrared spectroscopy (IR), have been effectively used for a considerable amount of time in order to analyze the structures of the complex molecules. In hydrogen bond studies, such procedure work particularly well and it is paired with the direct structural analysis instruments. An approach for the direct, quick, and low-cost measurement of the paracetamol composition in the solid pharmaceutical products was created using transmission FTIR spectroscopy. This approach analyzed the paracetamol content immediately without solvent extraction. This technique avoids per-samples preparation and does not require large volumes of hazardous solvents or complex runtimes. This is the result for the FTIR analysis of paracetamol. I will be slowly explaining and analyzing the functional groups that are present in the paracetamol. So firstly, this FTIR will be divided into the two reagents, which are functional groups reagent and also fingerprint reagent. Alright, so firstly, let's look at the broad peak at the 3163.26. This indicates the presence of the stretching band of the phenol functional groups. Next, the peaks around 3317.56 shows the functional group of the stretching amide, the single bond of NH. The peak around 1653 indicates the presence of the stretching amide, C double bond O. Paracetamol also contains of the aromatic ring, which indicates by these three wave numbers. The wave number that peaks at 1323.17 indicates the presence of the functional groups for amide, a certain single bond of CN. And these two peaks indicates the presence of the single bond of the carbon and hydrogen, which indicates the functional groups for the N-aromatic ring. And there are additional peaks around 800 until 1200. The peaks 3 here, the 3 peaks, attribute to the various CH bending and also CH stretching vibration. This also might indicate to the presence of the contaminants and also the impurities in the paracetamol. Lastly, in the fingerprint reagent, there are multiple peaks there also, which are 830.96, 794.67, 694.37, which indicates an attribute to the complex bending vibration of the aromatic ring and also other structural features. So this is the final result analysis for the FTIR analysis of the paracetamol. So this is the summary discussion on the spectra for the FTIR analysis of paracetamol that I have analyzed previously. So paracetamol have the functional groups of phenol, amide, aromatic ring, and also some additional peaks of CH bending and also CO stretching, and also a few peaks at the fingerprint reagent. There are quantitative and qualitative achievements that I have obtained from the previous analysis of the paracetamol. So for the quantitative, we have calibration curve development by developing a correlation between known quantities of standard solutions and also the strength of certain absorption bands associated with the analyte. Plotting absorbance versus concentration and creating a linear relationships are the fundamental components of calibration curve. This makes it possible in order to quantify the amount of paracetamol that is present in the identified samples. So for the peak area integration, the peak reagents correspond to the certain paracetamol absorption bands that are integrated by processes of FTIR spectra. Assuming that the procedure has been correctly calibrated and verified, the area under the curve corresponds to the compound's concentration in the sample. For qualitative achievement, we have functional group identification. Characteristic absorption bands seen in the FTIR spectra are representative of particular functional groups found in paracetamol molecules. For example, the hydroxyl group, phenol, OH stretching is shown by the presence of peaks at 3163.26, whereas the amides group, C-double-bond-O stretching is indicated by the peaks about 1650. Functional groups in paracetamol can be qualitatively identified by comparing the experimental spectra with database or reference spectra. For structural confirmation, through the comparison of the measured absorption bands with those predicted by the chemical structure of the medication, the FTIR spectra can verify the molecular structure of the paracetamol. By doing so, the compound's identification and purity may be confirmed.
The next part is advantageous FTIR analysis of paracetamol. First, we can get the specific identification of functional group, which is we can identify the specific absorption bands corresponding to certain functional group in paracetamol molecule. For example, hydroxyl, amine, carbonyl, and aromatic rings. Next is the accuracy. FTIR make it possible to accurately determine how much paracetamol is present in the sample by establishing a correlation between the strength of absorption band and known quantities of paracetamol standard. For the third one is rapid analysis. This method is quite rapid and involves minimum sample preparation compared to other analytical methods, which is it yields quick result by making it appropriate for routine quality control and process monitoring in pharmaceutical manufacturing. On the other hand, for sensitivity, it is very sensitive to even minor changes in molecule structure, which is it enables the identification and contaminants or modification in paracetamol formulation. This analysis ensures that product quality and safety. And then for the robustness, it is measured by evaluating certain parameters throughout the method, which is its validate process include changes in instrumental parameters, sample preparation technique, pH solution, and stability, which can guarantee the method long-term performance. The next part is the limitation of FTIR analysis on paracetamol, which is the detection limit. They have the ability to identify signals that correlate to small changes in the way that molecule absorb infrared light. Throughout the analysis, we need to increase the signal-to-noise ratio by averaging multiple scans or improve the signal processing technique to reduce the detection limit. Another limitation for FTIR analysis is sample preparation must be done correctly, because when it comes to paracetamol, improper sample preparation such as using a wrong formulation or matrix may have an impact on the precision as well as consistency of the findings. Other than that, FTIR also have limitation on quantitative analysis. Even though FTIR can offer qualitative insight into the functional group found in paracetamol, the accuracy is less than other methods such as HPLC, high performance liquid chromatography, that have a more accurate readings. There are some improvement on limitation that we can do throughout the analysis of FTIR, which is the first one is signal-to-noise ratio enhancements. Here, we can improve the signal-to-noise ratio by adjust the aperture size, detection sensitivity, and number of scans, among other measurement parameters. Analyte also more detectable as a result, especially at lower concentration. Moreover, we need to improve the sample preparation, which is we can improve the interaction with the infrared beam by improve the sample formulation. For example, for the solid sample, method like thin film deposition, KBR, this preparation or pelletizing should be taken into consideration to guarantee the consistency and repeatability sensitivity of the sample matrix. The last improvement on the limitation FTIR is using a hypernated technique, which is FTIR with additional analytical methods such as mass spectrometry or mass chromatography to increase the selectivity and sensitivity. Other than that, hypernated method can enhance the detection limit and offer complementary information by concentrating on certain analyte of interest. As you can see here is some references that we refer throughout the assessment. That's all from us. Thank you.